Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 6 of 21. Using a standard float might seem harmless until your aggregation query silently miscalculates millions in financial transactions. Code that runs perfectly can produce numbers that are slightly, dangerously wrong. This is exactly why we need to talk about the perils of precision. In PySpark, you have three primary ways to store numbers with fractional parts. You have FloatType, DoubleType, and DecimalType. They are not interchangeable. A common mistake is letting PySpark infer a schema from your raw data. Inference usually assigns DoubleType to any number with a decimal point. If you are calculating financial revenues, relying on this default behavior is a serious operational risk. To understand why, we need to look at how FloatType and DoubleType function under the hood. FloatType uses 32-bit IEEE 754 floating point math. DoubleType uses the 64-bit version of the same standard. Both represent numbers as binary fractions. Think about how the fraction 1/3 cannot be written perfectly using base 10 decimals. It becomes an endless string of threes. The exact same limitation exists in binary. Common decimal numbers like 0.1 or 0.2 cannot be represented perfectly in base 2. The computer stores a tiny approximation. With DoubleType, you get 64 bits of space, meaning the approximation is incredibly close to the real number. If you query a single row of data, you will rarely notice the difference. Here is the key insight. The error compounds during aggregations. When you calculate total financial revenues by summing up billions of individual rows, those microscopic inaccuracies add up. A fraction of a cent lost or gained on every transaction eventually skews the final aggregate total by thousands or even millions of dollars. Your aggregation logic is mathematically sound, but the underlying data type corrupts the result. If your system is calculating physics simulations or training machine learning models, FloatType and DoubleType are exactly what you want. They trade exactness for high-speed hardware processing. But the moment you handle money, you require strict, unyielding accuracy. This brings us to DecimalType. DecimalType does not use floating point approximations. It stores numbers exactly as you define them, using a fixed scale. When you configure a decimal type, you define two distinct parameters. First, you specify the precision, which is the maximum total number of digits the value can hold. Second, you specify the scale, which dictates the exact number of digits allowed to the right of the decimal point. If you set up a decimal type with a precision of 10 and a scale of 2, PySpark allocates the exact space needed to store that value down to the penny. There are no binary fractions and no rounding guesses. In practice, you implement this by taking strict control of your schemas. When reading financial records from a source file, do not let PySpark guess the types. First, you create a strict schema object. Then, you define your financial fields, like revenue or tax. Finally, you explicitly assign them a decimal type with your chosen precision and scale. Once your data frame loads with this schema, your standard sum or average aggregations will execute perfectly from the first row to the billionth. You sacrifice a minor amount of compute performance compared to a standard double type, but you guarantee that your financial reporting is absolutely flawless. The rule is simple. Use floating point types for speed and scientific approximations, but the moment a number represents currency, lock it down with a decimal type. Thanks for tuning in. Until next time.